In this unit, we will introduce the concept of ballot or round array. This concept will help understanding Paxos and sequence Paxos. A ballot array describes the state of the acceptors at each round. Given this, it will be quite easy to go through the correctness argument for sequence Paxos. We will then proceed by transforming the correctness proof of Paxos to sequence Paxos and prove the properties of sequence consensus. So how do we know that the algorithm is correct? We are going to build on the structure of Paxos. So let us look again to the algorithm. So on propose, you start the prepare phase and you collect promises, if you remember that. And you collect promises from a majority. This is the prepare phase. And the sequence at the highest round number is adopted. This is the important thing, this one. And is extended, you can see here. Once this is done, you start the accept phase and collect from a majority. And if so, that is possible, then you decide. You collect from a majority an acknowledgement that they have accepted the value that you proposed, and then you decide. In other cases where there is no promise that is higher than what the proposer promised, you abort. And this is the case with the abort here. And as we remember, when you decide, you just look for decisions of sequences that are longer than the sequence that you have decided before. So now we are going to introduce the concept of ballot or round array. The ballot array represents the state of the acceptor at each round after an accept phase. Okay, after an accept phase. This is very important. So here we have three replicas, P1, P2, and P3. These are also the acceptors. And here we have a ballot array. You can see here we have the round number at each row, and you see the acceptors. We call them P1 to P3. So initially, all acceptors have accepted the empty sequence that is at round 0. At round 1, one acceptor has accepted a sequence consisting of C1. But at round 2, acceptors P2 and P3 has accepted the sequence C2. Observe at this stage we have a majority for the sequence C2. And also observe that at this round P1 did not accept any sequence. The latest sequence accepted by C1 is. And observe also that P1 did not accept any sequence. The latest sequence accepted by P1 was at round 1, which is C1. So we are looking at the state of the acceptors, as you can see. Now we will introduce a concept which is very simple. It is a concept of a majority that have accepted a sequence. So the concept we are going to discuss now is what we call a chosen sequence. So let us try to define the notion of a chosen sequence properly. We say that VA, which is the accepted value by acceptor P at round n, is the sequence accepted by acceptor P at round n. So, for example, at round 1, the sequence accepted by acceptor P1 is sequence consisting of C1. So the next concept is what is a sequence V chosen at round n. So a sequence is chosen at round n if there exists a majority of acceptors, that's what we call a quorum, a majority quorum of acceptors at round n, such that V is the prefix of the value of those acceptors for every acceptor here, for every acceptor. So let us see what we have here. So let us look what is the sequence accepted at round 2. At round 2, we have a quorum here. This quorum accepts the sequence consisting of C2, but also it accepts the empty sequence. So, because there is a majority for the sequence consisting of C2, and there is a majority at round 2 also for the empty sequence. Whereas at round 1, if you take any quorum here, for example, you take these two processes, or these two processes, or this one and that one, you will find the only chosen sequence in this case is the empty sequence. So the chosen sequence requires that a majority has accepted this sequence, or this sequence is a prefix of another sequence that is chosen at that round. So we say a sequence is chosen, for example, any sequence, if D is chosen at round n for some round n. Now let us, just for more understanding of this concept of ballot array and chosen sequence, look to enumerate the chosen sequence at different rounds here. And this is still also very instructive. So here is the situation. The chosen sequence here is empty sequence. Here the chosen sequence is the empty sequence, because there's no majority for C1. Here is the chosen sequence is C2. So if we look here, after a sequence C2 is extended by 2 elements here, we see that longest chosen sequence at round n is C2 followed by C3 followed by C1. So if you look here, so what are the chosen sequence? Of course, it is the sequence C2, C3 followed by C1 and all its prefixes. So the empty sequence is chosen, the sequence of C2 only is chosen, C2, C3 is chosen, and C2, C3, and C1. Okay, so now we understand the notion of chosen sequence.